Okay, you should have this pink sheet in front of you. This is the SOL formula sheet. You can use this for anything that we're doing in chapter 11 and 12. That includes tests, quizzes, projects, anything that we're doing. You'll also be given a clean copy of this when you take the SOL in May. In 11.1 and 11.2, which is what this video is going to focus on, we're going to be talking about that first row of area formulas. These are pretty straightforward. I just want to go over some quick examples and have you practice it, and then we'll move on. So I just want to point out a couple things to remember. Area of a triangle, 1/2 times the base times the height. The base and the height have to be perpendicular depending on what the triangle looks like. That could look a little different, but what you need to remember is the base and the height have to be perpendicular. Area of a rectangle, length times width. Area of a parallelogram, you have the base times the height. Remember, the height has to be perpendicular. Area of a trapezoid, remember you have two bases and the bases are the ones that are parallel. The height has to be perpendicular. So 1/2 times the height times the sum of the bases. So let's go over some examples. On page 721, we're going to go over these three examples. It asks you to find the perimeter and the area. So perimeter is just the sum of all the side lengths of the outside. Area, of course, is the inside. So number one is a triangle. So I'm going to flip over back and forth here. It looks like I did number 2 with you. So looking at number 2, we have a base of 30 and we have a height of 17. So when you use your formula sheet, the one that I used was this formula. So base times height. So when I did that over here, the base times the height gives me 510 square units. Remember, area is units squared, perimeter is just plain units. When we're adding up all 4 sides, again, it's going to be 30 plus 20 plus 30 plus 20. So it's like a fence that goes up the sides. It goes around the sides. So when I add up all the sides, I get 100 units. The next one I did was number 3. So for number 3, the base is not given to you, but the height of 5 is. The 13 we'll use for perimeter, but we won't use that one for area. So the first thing I had to do was do the Pythagorean theorem to find the base, and then I found the area and the perimeter. So Pythagorean theorem, I found the base of 12. So when I added up the 3 sides, I had 12, 5, and 13. So the perimeter is just 30 units. Remember, that's plain units. Area is 1/2 times the base is 5, the height is 12. So my total area is 30 units squared. The next problem that I did was example 2 on page 722. So in this problem, it says the base of the triangle is twice the height. The area of the triangle is 36 square inches. Find the base and the height. So you have to work backwards with this one. Looking at the picture that's given to you, it says that the base is twice the height. So if the height is h, the base has to be 2h. Plugging it into my formula for the area of a triangle, remember the base is 2h, the height is h. You can see the way the book did this, and I did it exactly the same way. You combine 2h and h and got h squared. The 1/2 times the 2 becomes 1, so technically that disappears. And we should know by now how to solve this. Square root both sides. So the height of the triangle is 6, and then the base is 6 times 12, which is, or 6 times 2, which is 12 inches. I also did the guided practice number 4 at the bottom. It says a parallelogram has an area of 153 square inches and a height of 17 inches. What's the length of the base? So what I did, I started off with my formula, area equals base times height. I know that the area is 153. I don't know the base, but I know the height is 17. Just like anything else, we're going to work backwards and find that the base is 9. I did adjust the homework, so you can see I crossed some things out. What I have written here is your homework for 11.1. You do have homework in 11.2 also. So if you want to pause here and copy down the homework, there's your homework for today. Moving on to 11.2. So 11.2 notes, we're finding the area of trapezoids, rhombus, and kites. These are not necessarily on your pink sheet, on your SOL formula sheet, but they're pretty straightforward problem or formulas. Let's look at the area of a trapezoid. This one is on your formula sheet. This one's the half the height times the sum of the bases. Again, the base and the height have to be perpendicular. area of a rhombus. This one says 1/2 times D1 times D2. Those are diagonals. So when you look at this rhombus, this is one diagonal, this is the other diagonal. So you're multiplying the diagonals and dividing by 2. Exactly the same formula for the area of a kite. We have it out here because it's hard to define this entire length, but what we're looking at is half the product from here to here times this to this, that length, and then divide by 2. That formula is not on the formula sheet. Let's look at the guided practice on page 731. So I did all 3 of these for you. If you take a look at the first one, it says find the area of the figure. So 8 and 6 are my bases and 4 is my height. So when I did that problem, I plugged it into my formula. Pretty straightforward. I got 28 square feet. The next one, number 2, to find that area. One diagonal is 6, the other diagonal is 14. So when I plug that into the formula, 6 times 14 times 1/2 gives you 42 square inches. Number 3, one diagonal is 80, the other diagonal is 60. Be careful what they're showing you. So when I plug that in, 1/2 times 80 times 60, I get 2,400 meters squared. So if units are given in your problem, make sure that you put units in your answer. Sometimes the book gives you units, sometimes it does not. I have 2 more problems to go over with you. So the guided practice on page 732, here's the problems here. Number 4 says the area of a kite is 80 square feet. One diagonal is 4 times as long as the other. Find the diagonal lengths. So what I did was plug in 80 for the area. One diagonal is x, the other diagonal is 4x. Working backwards, I found that one diagonal is 6.3. The other one has to be 4 times that, which gives me 25.2 feet. The last one, it says, find the area of the rhombuses with vertices M, N, P, and Q. So to find that area, you have to have the diagonals. So you can see how I drew myself a picture, M, N, P, Q. So to find those diagonals, I need to find this diagonal here, that length from M to P, and then the length from N to Q. That's my diagonals. I don't want the sides, I want the diagonals. So I did my distance formula and I found those 2 diagonals to have a length of 8 and 4. My formula says multiply the diagonals and then multiply by 1/2, which gives me 16 square units. So I want you to be able to use the formulas and then be able to work backwards from the formulas. Here's your homework for 11-2 if you want to copy that down, and then do 11-1 and 11-2 homework. You will have a quiz on this next time I see you.